Welcome to section 1.5, Inverses of Functions. At the end of this section, we'll want to be able to answer these questions. First, what is the relationship between a function and its inverse, both mechanically and graphically? Second, is the inverse of a function always a function? Third, if the inverse of a function is also a function, how do we describe the original function? What terminology would we use? How do we sketch inverse relationships? Even better, how do we graph inverse relationships? And finally, what happens when we take the composite of a function and its inverse? So f inverse of f of x is equal to what? Or f of inverse of x is equal to what? Let's start with what exactly is the relationship between a function and its inverse. If our original function looks like this, price versus diameter, then our inverse function comes about, as we recall from earlier math classes, we switch the x and the y values. So now, instead of price versus diameter, our graph is a graph of diameter versus price. And every original x value on the graph is now a y value, and the corresponding y value is now the x value. So let's take a look at an example here. Given the equation y equals 0.5x squared plus 2, write the equation for the inverse relation by interchanging the variables and transforming the equation so that y is in terms of x. So, given y equals 0.5x squared plus 2, the first thing I'm going to do is interchange the variables. So now my new equation will be x equals 0.5y squared plus 2. Now we need to solve for y. So I'm going to subtract 2 and get x minus 2 equals 0.5y squared. Now I'm going to divide by 0.5, which is the same as multiplying by 2. And I will get the equation 2x minus 4 equals y squared. From there, I'm going to continue to solve for y. So I'll take the square root only I have to remember when I take a square root that I'm actually, I have two answers, plus or minus. So now we have an equation for y. Plus or minus the square root of 2x minus 4. The next thing we're asked to do is actually plot the function and its inverse on the same screen using equal scales for the two axes. And explain why the inverse relation is not a function. So let's go into our calculator. And you'll see I've already plugged the information in for y, the original function, 0.5x squared plus 2. Now that plus or minus, our calculator doesn't have a plus or minus, so I actually have to break the equation into two parts, the positive and the negative. So in y2, I put the positive expression, the square root of 2x minus 4. In y3, I put negative y2, which means take the information in y2 and multiply it by negative 1. Saves me a lot of time. Let's plot the function and its inverse. Right now, let's look at the graph. Here's our original function. There's the top half of our function. and there's the bottom half of our inverse. explain why the inverse relation is not a function. If we go back and take a look at the graph, we can see that when we look at the graph itself, let's pull that over into our board. If we take a look at the inverse function here, we can see that for values of x where we have values of y, we actually have multiple values of y, which violates the definition of a function. We have two values of y for the same value of x. Finally, we're asked to plot the line y equals x on the same screen. How are the graph of the function and its inverse relation related to this line? Let's go back to our calculator. And we'll turn on that line y equals x. Down. Turn it on. And look at the graph. We can see that that line y equals x creates a certain amount of symmetry. In fact, the way we describe that symmetry is that our inverse is a reflection of the line of the original graph over the line y equals x.